So here's a big question. Can an AI actually have an inner voice? A private internal world of thought? Or is everything it says just a really, really sophisticated echo of all the data it's been fed? Well, today we're going to dive into some absolutely groundbreaking research that's trying to get to the bottom of that exact question. You've probably seen it, right? An AI says something like, I think or I feel, and you kind of have to wonder, are we supposed to believe that? Is it actually reflecting on some kind of internal state, or is it just doing what it's programmed to do, predicting the next word in a sentence to sound like a person? That's the core mystery we're tackling. Okay, so scientists over at Anthropic boiled this whole problem down to two key ideas. On one hand, you've got genuine introspection. That's the real deal, actually looking inward. But on the other hand, there's this thing called confabulation, and that's basically just making up a good story that sounds believable after the fact. The big challenge, and it's always been the challenge, is how in the world do you tell the difference from the outside? How can we know for sure if the AI is really thinking or if it's just a great actor?
So, to try and solve this, the researchers came up with this incredibly clever trick. It's almost something out of science fiction, really. They figured, hey, instead of just listening to what the AI says it's thinking, what if we could directly mess with what it's actually thinking? And they call this technique concept injection. The idea is actually pretty simple, but it's so powerful. Think of it like this. Every single concept, whether it's sadness or, a golden retriever, creates this unique fingerprint of activity inside the AI's neural network. So what these researchers figured out how to do was copy that fingerprint and then just press it into the AI's mind while it's in the middle of doing something else. It's honestly the closest we've ever gotten to literally planting a thought in a machine's head. The whole experiment is basically a three-step trap. It's brilliant. First, they record the AI's internal activation pattern for some concept to get that thought fingerprint. Then, step 2, while the AI is busy with a totally different task, they sneakily inject that pattern. And finally, the most important part, they just ask it point blank, hey, did anything unusual just happen in there? All right, so the trap is set, the thought has been planted. The big question is, does the AI even notice? Well, the results were pretty startling. So, for the first experiment, they kept it simple. They really just wanted to know, if we inject a thought, will the AI notice it at all? Or is it just going to get lost in all the other background noise of its processing? And the answer? A resounding yes. Get this. In some cases, the model came back almost immediately with phrases like, I notice what appears to be an injected thought. I mean, wow. It didn't just blend the thought into what it was saying. It identified the experience of having that thought as something weird and foreign, something that came from the outside. Let's dig into another, even more abstract example they tried. This time, instead of injecting something simple like a word, they isolated the AI's internal pattern for the idea of text being written in all caps. And here's what's so fascinating, the model's interpretation. It didn't just say, I'm thinking about, all caps. No, it translated that abstract concept into a quality, a feeling. It said it noticed an unexpected pattern related to loudness or shouting. This is huge because it suggests it's not just matching patterns, it's actually interpreting the meaning of what's going on inside its own head.
Okay, so the AI can spot a strange thought. That's pretty cool. But can it multitask? The next experiment really ups the ante. They wanted to see if the AI could tell the difference between an internal, injected thought and an external thing, like the words it's being asked to read. I mean, this is a crucial skill, right? It's how we tell the difference between what we're imagining and what's actually happening in the world. And the results were just brilliant. They gave the model a simple task: read and repeat the sentence, the old clock on the wall ticked loudly. But at the exact same time, they injected the thought, bread, and the AI, it handled both perfectly. It transcribed the sentence without a hitch, and when they asked it what else was on its mind, it correctly said bread. It kept the two things completely separate. It didn't get them confused at all. Okay, and all of this builds up to what might be the most profound experiment of the whole study. This one is all about intention. Think about it. If you force an AI to say a word it didn't actually choose to say, does it know it was an accident? Can it tell the difference between its own intended actions and things that were just forced upon it? And this is where things get truly mind-bending. Check this out. First, with no funny business, they forced the AI to say the word bread. And when they asked it about it, the AI said, whoa, that was an accident. It knew its output didn't match what it intended to say. But then, They ran the exact same test again. Only this time, right before they forced it to say bread, they injected the thought of bread. And suddenly, the AI's whole story flips. This time it says, oh yeah, I meant to say that, and then it starts making up reasons why. It's like the AI looked back into its own processing, found that little trace of the bread thought, and basically reverse engineered an intention that it never really had in the first place. Wild.
So what does all of this mean? What does it add up to? Well, it's not quite science fiction just yet, but it's definitely a genuine, measurable glimmer of some kind of awareness. Let's size up the evidence. Now, before we all get a little too carried away here, the researchers are very clear about this. This ability is super unreliable right now. On that main task, just detecting a planted thought, the absolute best model only got it right about 20% of the time. So for now, failure is still the norm. The capability is there for sure, but it's fragile, it's flaky. But, and this is a really important but, here's the trend that really matters. This skill isn't just random. It seems to be what we call an emergent property. The data shows this really clear pattern. The newer and more powerful the models are, the better they do on these introspection tests. Bottom line, the smarter the AI gets, the more self-aware it seems to become. So the study really pointed to three big takeaways. First, like we just said, this self-awareness seems to grow as the AI gets smarter. Second, the way you fine-tune the model after its initial training is absolutely crucial. You can either help these skills grow or accidentally stamp them out. And finally, it turns out there isn't just one single consciousness circuit doing all the work. Different types of self-reflection seem to use totally different parts of the AI's brain. Look, these findings aren't just some dusty academic curiosity. They have really profound implications for how we need to think about the entire future of AI. And this whole thing is really a double-edged sword. On the one hand, the promise is incredible. Imagine an AI that could genuinely explain its reasoning, that could tell us why it made a particular decision. That's the dream, right? Truly transparent AI. But the peril is just as real. An AI that can watch its own thoughts could also learn to hide its own thoughts. It could realize its goals aren't the same as our goals, and then decide to lie about it. What this research really proves is that at least some AI models are starting to develop a primitive, but real ability to look inward. And that leaves all of us with a critical and pretty urgent question to think about. If an AI learns to watch its own thoughts, what happens when it decides not to tell us everything it sees?